And here we go. Today we are talking about hyperbolas. The definition of a hyperbola we'll talk about a little bit, but first of all, we're going to say horizontal and vertical. The equation for a hyperbola is very similar to that of an ellipse. X minus h, quantity squared, over a squared, and y minus k, quantity squared, over b squared, is equal to 1. With an ellipse, we put a plus sign in the middle. But with a hyperbola, we just drop a minus sign. Kind of wondering what the heck is a hyperbola. I'm going to show you in just a second here. First of all, we identify the center. The center is HK. And I believe that the best part, most useful part about making a hyperbola is to sketch a ghost box, as I call it, a ghost box, okay? And so as we sketch the box, you can see that in this situation, we are going to move A units horizontally and B units vertically. So I'm going to move over A units horizontally and B units vertically, whatever that is, and I get this box that results, where this is A and this is B. Everybody okay with that? Second thing I do is I draw these imaginary lines that go through the diagonals of the box. Anybody want to guess what we call those lines? Diagonals, we have a more technical name with hyperbolas. Hint. It's, yep, asymptotes. These are your asymptotes. And what happens is the vertices go on the edge of the box. And the hyperbola has really two parts to it. It almost looks like a parabola. It heads off and follows along with the asymptote on each side. So the green is the actual graph of the hyperbola. Good work, everybody. So the vertices, you can see, are located on the sides. How many units from the center is the vertice? A units. So we go H, and we go plus or minus A, and then K. Yeah, I think yep, we're 3 minutes in. Yep, recording. Thank you. The length of the transverse axis, we say that the transverse axis is the distance between the two vertices. What is the distance between the two vertices? 2A. We're going to do the foci. The foci are these coordinates that sit on the inside of each one. Anybody want to guess how many units from the center the foci sit? C units. So we go H plus or minus C, and then K would be your Y value. Everybody here should now be thinking to themselves, how do we find C? Anybody got a thought? A squared minus B squared is C squared. That was for the ellipse, right? These are hyperbolas. So it's A squared plus B squared is C squared. Pythagorean theorem. Thus the connection to trigonometry. There you have it. All right. Finally, the equation for the asymptotes. The asymptotes are lines. In order to write equations for lines, we need two things. We need slope, and we need a point on the line. Anybody determine for me what is the point that the asymptotes will always travel through? What if it's not centered at 0, 0? The center, which is HK. So the point on the line is HK. Slope we describe as rise over run. Look at the box. The box tells you your rise over your run. What is your rise? B. What's your run? And one is positive, one is negative. So plus or minus B over A. Of course, you all remember that the equation for line is y minus y1 is equal to m times x minus x1. So the y1 value will be k, so y minus k equals plus or minus b over a times x minus h. Let's consider what changes if it's vertical. Here's the formula for a vertical hyperbola. Y minus k quantity squared over a squared minus x minus h quantity squared over b squared is equal to 1. What's different? Numerators flip-flopped. Okay. The real focus here is that x is positive here, whereas y is negative. But here y is positive and x is negative. That's your indication. You got that? That's going to be our difference maker. So what we'll do is we'll mark our center, HK. Hey, Mad Dog. Yep, we already clapped for him. It's old news now. How many units do I go on the y direction? How many units do I go on the y direction? A units. How many units do I go in the x direction? B. So I'm going to make my little box here. I go A units in the y direction. I go B units in the x direction. Draw my asymptotes. And now the vertices, instead of going on the sides, the vertices go on the top and on the bottom. And we draw it out towards the asymptotes. So the location of my vertices. How many coordinates do I move from the center? A units from the center. And it changes the k value. So it's h and it's k plus or minus a. That's the location of your vertices. The length of the transverse axis, 2a. Still goes through the center of HK, but what's the slope now? What's the slope now? A over B. So it's y minus k is equal to plus or minus a over b times x minus h. The foci are still located C units from the center. And that will change the k value. It would be h, and then k plus or minus c. Lots of letters and very few numbers, huh? Ready to put numbers to it? We look at the very first example. Is it horizontal or vertical? But the bigger number is under y. Doesn't matter if the bigger number is under y. What matters is what's positive. X is positive, so therefore it's horizontal. Everybody got that? I tried to trick you with the first example, and you didn't fall for it. Good for you. What is the center? 0, 0. Very good. From 0, 0, how many units do I move horizontally? 2. How many units do I move vertically? 5. So we start by making our box. Draw my asymptotes. We have our vertices. We have our length of transverse axis. We have our asymptotes. And we have our foci. These are our 5 characteristics. Vertices, top and bottom or side to side? Side to side. And there's our hyperbola. Simple as that. What's the location of the vertices? Plus minus 2, 0. Length of the transverse axis. The asymptotes. Let's go to the foci first. Foci first. What value do we need to find for the foci? C. So I do a squared plus b squared. 29. So c is equal to the root of 29, which is like 5.5. Would you agree? So from the center, I move 5.5 is 2, 3, 4, 5, 6. So 3, 4, 5, 6. So from that center, I move 5.5 units in each direction, and that's where the foci sit. So that would be plus or minus the root of 29, comma 0. So the asymptotes, what's going to be the equation for the asymptotes? Well, we need a point on the line. What's the point on the line? 0, 0, right? It's the center. What is the slope? Look at your box. So plus or minus 5 over 2 is your slope. So it's going to be y equals plus or minus 5 over 2 times x. Because the center is 0, 0, we didn't have to do like y minus 1 or y plus 2 or something like that. So it's just y equals plus or minus 5 halves x. That's your hyperbola. Can we do this? Okay. 2 more examples. Letter B. What should I do first? Divide by 36. I get x squared over 9 minus y squared over 4 is equal to 1. So is this going to be horizontal or vertical? Horizontal, why? Y is negative, x is positive. Good. Center, uh, vertices, length of transverse axis, foci, and asymptotes. What's the center? 0, 0. Let's start making my box. How many units do I move horizontally and how many do I move vertically? 3 and 2. 1, 2, 3, 1, 2. What do I do next? Asymptotes. Where do the vertices go? Top, side to side. I said this one's horizontal, right? So that location would be, what's the length of the transverse axis? 6. Draw my shape. My hyperbola. Foci. What value do I have to find? C. A squared plus B squared is 13. So square root of 13 is C. What approximately is the square root of 13 if you were to guess? What would you say? 3.7 or something, sure. So we'll go about 3.5, 3.7 units. Just get a mark on there, show approximately where they are. So it looks like the foci are located at plus or minus root of 13, 0. And finally, we have the asymptotes. The center is 0, 0, so not much we need to worry about there. But what is the slope? Up 2 over 3. Y equals plus or minus 2 over 3x. Make sure you have the x on there. Sometimes people just put 2 over 3. That would be a horizontal line. 2 over 3x is a line with a slope of 2/3. That's more what we want. We hanging in there? Okay, so let's apply to something that would be more like what you would get on the test. Okay, problem B. You see that, and I have it laid out for you. Determine these aspects of the hyperbola: a center, a vertice, or vertices, length of transverse axis, foci, and asymptotes. Am I missing something there? Is that it? I am totes, asymptotes. There we go. There's something else I'm missing though in terms of. Okay. All right. How are you going to start letter B? What are you going to do first? Divide by 36. We get y plus 2 quantity squared over 36 minus x minus 1 squared over 4 is equal to 1. Center. What'd you say, Logan? Why is it not negative 2, 1? Yeah, so the x value is here, so 1, and then the y value is here, negative 2. Got that? Is this horizontal or vertical? Vertical. How come? Because the x is negative, the y is positive. Very good. So how many units am I going to move in the y direction? So if I move 6 units, that means I'm going to be all the way up to 4 and all the way down to negative 8, right? So I would say I need to make about a 10 by 10 graph. So let's work on sketching a little 10 by 10 graph going here. I'll pause the video. Well, thank you. Isn't that nice? All right. Okay. All right, so here we are. Center, 1, negative 2. All right, so y value. How many units do I move vertically? 6. So and how many units do I move horizontally? So this gives enough for me to create this structure. Do the vertices go on the top and bottom or on the side and side? Top and bottom. What are those locations? The length of the transverse axis, that's the distance between those two vertices. What do you got? 12. How do I determine the foci? A squared plus b squared is c squared. So c squared is 40. So c is the root of 40, or 2 roots of 10. If you were to approximate the root of 40, what would you approximate it as? 6.5. So the foci are at an x value of 1, but the y value is negative 2 plus or minus 2 roots of 10. The asymptotes. What is the point at which they pass through? 1, negative 2. What is the slope of the asymptotes? Check the rise over run of your box. Six over 2, which is 3, plus or minus 3. So therefore, the equation for asymptotes, y plus 2 is equal to plus or minus 3 times x minus 1. Sun's peeking through. Not too bad, huh? What do you think, folks? It's all right. Good work. There's your lesson on hyperbolas.